If process safety information is the foundation of a PSM program, then P&IDs are the cornerstone. An engineer or technician who desires to familiarize themselves with a chemical process will often first turn to the P&IDs because of the detailed equipment information included on the diagrams. A P&ID is a diagram that depicts the interconnection of process equipment and instrumentation. The term P&ID is an acronym for Piping and Instrumentation Diagram. As a drawing, a P&ID includes all the process equipment, interconnecting pipes, manual valves, control valves, and process-related instrumentation as necessary to fully represent and understand the system. A good P&ID will be equipped with a clear legend of symbols to assist in diagram interpretation. P&IDs utilize detailed annotations to describe the pipes and equipment. Examples of typical annotations include equipment name, equipment specifications such as model number, serial number, and dimensions, valve equipment tag ID number, pipe service, which indicates the purpose of the pipe, flow direction, page connectors, which will need to be followed to track the pipe from one page to another. A P&ID of a small system may fit on a single page, while a complex chemical process may be hundreds of pages. P&IDs are a fundamental requirement of the RMP PSM CalArp regulations. Specifically, when developing and organizing process safety information, a facility must ensure that the information pertaining to the equipment in the process includes P&IDs. Additionally, P&IDs are an essential tool for any operator who seeks to fully understand their system. These drawings are particularly important for ammonia refrigeration systems, and IIAR standards encourage P&IDs to be developed as part of the system documentation in the non-mandatory Appendix B of IIAR Standard 9. How is the relief system design verified? How are the inventory calculations performed? What compressor-condenser capacity is available? Oftentimes, these questions can be answered in part by examining the P&IDs. If your system P&IDs are accurate, there is a high likelihood that your process safety information will be in good shape. On the other hand, if your P&IDs are incorrect, your process safety information is almost guaranteed to be riddled with inconsistencies. P&IDs are typically developed by the engineering team when a system is initially designed. After installation, the diagrams can be audited and corrected if inaccuracies are observed. Once corrected, the P&IDs are considered as built and fully reflect the system configuration. Unfortunately, many P&IDs have become outdated or lost altogether due to system modifications or changes in facility management. When changes to a system are vast or the drawings are misplaced, P&IDs can be developed from scratch, which is a labor-intensive and costly endeavor. Ideally, P&IDs will be utilized as a resource at your facility. Let's consider several ways you can incorporate these drawings into your normal business operations. Process safety regulations require that operating procedures be developed and implemented to provide clear instructions to safely conduct activities involved in a chemical process. The law requires that SOPs be consistent with the process safety information. If you accept the premise that P&IDs are the cornerstone of the process safety information, then the requirement could be rephrased to say that SOPs must be consistent with the P&IDs. Put another way, SOPs and P&IDs must not contradict each other. When an SOP specifies that a certain valve be manipulated, the P&ID must depict that valve. To ensure that SOPs and P&IDs are consistent, we suggest reviewing SOPs side by side with the P&IDs. Where actions are called out in an SOP, an operator should be able to identify the components referenced on the P&ID. RMP and PSM regulations require that process safety information be developed prior to conducting a PHA. Therefore, one can conclude that it is unacceptable to complete a PHA when the P&IDs are absent. But if having P&IDs available is simply viewed as a formality, the PHA team will not reap the benefits of these drawings. Often, P&IDs will assist in visualizing and analyzing the scenarios being examined. For example, many flooded refrigeration systems are configured with a liquid transfer vessel that is designed to move unwanted liquid on the low side of the system back to the high-pressure receiver. The piping that connects the transfer vessel to the high-pressure receiver and suction accumulator must have check valves to prevent reverse flow. A common PHA question for this component is what if a check valve in a transfer line fails, which could occur in the following scenario. The check valve between the suction accumulator and the liquid transfer vessel fails open, allowing high-pressure vapor to enter the suction accumulator when a transfer is initiated. Without the P&ID, it is hard to visualize what is occurring in this scenario. But if this were to occur, high-pressure liquid would enter the suction accumulator when the liquid transfer is initiated. This would result in tripping the high-level float switch or possibly slugging compressors with liquid. Preparation is critical for emergency readiness. At a chemical facility, an accurate P&ID is an indispensable tool to aid hazmat responders in making decisions during a crisis. With this in mind, P&IDs must be readily available to responders at all times. Often, chemical leaks can be stopped by closing a downstream isolation valve. The P&ID is an ideal resource to locate such a valve prior to hazmat team entry. The duration of many emergencies have been extended due to a lack of responder resources. Experience has shown that hazmat teams are reluctant to enter a chemical atmosphere until they have confidence that they can achieve their objectives. We advocate that P&IDs be included in the training program for operators of PSM processes. Due to the complexity of the diagrams, it is important for operators to regularly interact with P&IDs to improve their ability to use them. Here are some suggestions on how to incorporate P&IDs into operator training. Give an operator a pencil, paper, and clipboard. Challenge him to sketch a P&ID of a single component from scratch. Once completed, compare the hand-drawn P&ID to the official drawing and note any differences. This type of training can be expanded to include multiple components as the operator gains competency in understanding P&IDs. Place a ribbon on several valves and note the valve numbers on the P&ID. Inform the operator which valves you have tagged and task him with retrieving the ribbons. This exercise will demonstrate whether an operator can use a P&ID to locate specific valves. Create a modified P&ID of your system that incorporates inaccuracies. Assign an operator the responsibility of auditing the P&ID and see how many of the errors he can discover. Examples of modifications that can be made are reverse some flow direction arrows, remove valves, move pipeline connection points, rename components. A great way to maintain P&ID accuracy is to implement an effective management of change or MOC program. If used correctly, an MOC will initiate modifications to PSM elements that require attention when a facility or process change takes place. Assuming the scope of an MOC includes process equipment, the P&IDs will require amendment. Here is some food for thought when updating P&IDs during the MOC process. Prior to implementing changes, it may be prudent to redline the existing P&IDs by hand with a red pen. This method of depicting alterations is particularly effective for smaller changes to process piping and equipment. After the project is completed, the redline P&IDs should be audited so that the as-built drawings can be finalized using AutoCAD. If the MOC involves disconnecting equipment from the system which will not be physically removed, it may be wise to continue to depict the equipment on the drawing. This will save time later if the equipment is reconnected. When this occurs, we suggest clearly annotating the equipment on the drawing. As with other requirements, the mantra, "if it isn't documented, it didn't happen," applies to P&IDs. With that in mind, make sure that all P&ID modifications are recorded. A common way to capture P&ID changes is by including a revision history section on each page of a P&ID title block.